video, I'm going to work out one example of taking the limit of the difference quotient. Over here on the right-hand side in red, I have written the difference quotient, at least one version of it here, f of a plus h minus f of a all over h. There are a variety of other versions of this using x and delta x as another example, so it really doesn't make any difference what your textbook uses. The overall concept of the difference quotient will be the same. We're going to take a look at f of x is equal to 1 over x. So on each line, I'm going to have the limit as h approaches 0, and I'm going to do the difference quotient, so I'm going to take a plus h and plug it into the function. So I'm going to have 1 over a plus h minus, I'm going to take a and plug it into the function, so 1 over a, and then all over h. Okay? From here, I'm going to need to multiply through by the least common denominator. All right, in this scenario, my least common denominator is a times a plus h. So I'm going to multiply the top by an a times a plus h. I'm going to multiply the bottom by a times a plus h. When I do that, I'm going to distribute on the top, and the a plus h's are going to fall out. So my next line is going to look like the limit as h approaches 0 of a minus. Now when I distribute the second time in that numerator, the a's are going to fall out. I'm going to be left with the binomial of a plus h. And on the bottom, I am not going to distribute or anything. We're just going to leave it as h times the a times a plus h. That numerator is going to then simplify to the limit as h approaches 0 of a minus h, and then all over, again leaving that denominator, h times a times a quantity a plus h. Alright, in the numerator, we can see that a minus a is going to cross out. Alright, we can also hopefully see that would leave me with a negative h, and I've got an h in the bottom, so I could cross out the h right there, be left with a negative 1 with the h right there. That then is going to leave me down to the limit as h approaches 0 of a negative 1 over a times a plus h. At this point, I'm ready for a direct substitution. I can directly substitute 0 in for the h, and I'm going to have a negative 1 over an a squared as my final answer. So this is just one example of how you can go about taking the limit of the difference quotient, and specifically with a rational function, because most of the time examples that you find on the internet always focus on those polynomial curves. But when it is a rational function such as 1 over x, then you do end up with that complex fraction, and you've got to multiply through by that least common denominator in order to eliminate that and simplify it down as far as you possibly can. Definitely thanks for watching. If the videos are helping, share with your friends so they can benefit too, and don't forget to subscribe to the channel. Thanks.